Hi. So now we just got into the concept called logs. So we finished exponentials. So like y equal to 2 power x. So all these are 2 power x, 3 power x, and all these are like exponential. So when you plot the graph, it will go fast, right? Even in English, you can tell, oh, there is exponential growth. So that is called exponential. So generally we use these terms uh, exponential growth, where we see the exponential growth, like generally um, uh, we have seen the algae and all those things, so even virus, so all these things, like, okay, generally they go exponentially, like very rapidly. So initially it starts with 1, then 1 give birth to 2, then this birth give birth to 2, and this will give birth to 2, and this will give to 2, and this will give birth to 2. So all these things grow exponentially, like 1 becomes 2, 2 becomes 4, 4 becomes 8, 8 becomes 16. So these are all like exponential growth. So it will, within short span of time, it will increase to a uncountable number. So infinite, it reaches so fast. So that's the reason it is called exponential. That's the definition. Okay, let's come to log y equal to 2 power x. So we discussed everything. So before getting into this one, I'll give you few examples, like x equal to uh, y plus 5. So sometimes what we do, like, okay, we cut 5 from both sides. What will happen? So we can do this one, right? I subtracted 5 on the left side of the equals, and I can subtract 5 from right side. So I subtracted 5 from here, 5 from the right side too. So I can do this one, right? So you know that. And it will become x equal to x minus 5 equal to y. Sometimes we also write it like, when positive 5 goes on the other side, it will become negative 5. Right? So this is for the additions. What about the subtractions? When 2y equal to x, right? Here it is multiplying. So when this 2 goes on the other side, what will it become? It will become x by 2. That's what we write it, right? So now we have additions, like x plus 5 equal to y. 5 goes on the other side, it becomes negative y minus 5. So when 2y equal to x, when this 2 goes on the other side, it becomes x by 2. So we have seen. So here it is so what is this? Multiplying, division, or divided by. These are symbols, right? That's what we are doing there. So we are doing the plus, minus, all these are symbols. This is one symbol, this is divided by symbol, this is addition symbol, this is subtraction symbol. So nothing but when 2 into x equal to y, since it is multiplying here, it will go and it will be division. So likewise, here we are introducing, so it is not a symbol, it is like a short form of English word, log. Instead of logarithm, we are just writing log. So in these cases, when 2 to the power of x equal to y, I'm just swapping the positions, LHS becomes RHS. So I just put it here and this one here, 2 power x equal to y. So here x at the power position, when the 2 goes on the other side, we write it like log y base 2. This is how we denote. Just like don't no confusion, nothing. So when multiplying, it goes on the other side, it becomes division. When positive goes on the other side, it becomes negative. When negative goes on the other side of the equals, it becomes positive. When division goes on the other side of equal to, it will become multiplication. So multiplication and divisions are in sync. Positives and negatives are in sync. Log also will be in sync. So when when you write x, this 2 becomes base of it and y becomes the logarithm of it. And when someone says like, okay, log y base 3 equal to some k, if you want to like, okay, if you are confused with k or things, okay, p or something or whatever. So when 3 goes on this side and y becomes, it will pushes p up to the power and it becomes like this. Because we always call 3 as a base, log y base be 3. So base on the other side, base goes like this. So it is just swapping the position. How we do the multiplication and division, positives and negatives on the same way, just no confusion. So when write x and push this 2 on the other side, write log. So 2 power x, exponentials and logarithms. Exponential and logarithms. Multiplication, division, additions, subtractions. Exponential, logarithms. Like this. Exponentials, and if you write it like this, it will become logarithms. That's it. So base is important, and we called a special term when base equal to, when anything log k base 10 or log 100 base 10. So when the base 10s are there, we call it as a common logarithms. So it's a name given. Please don't get confused. It's a just name given. And why the specialty of common logarithms? We don't write the base. We just write log 100. When log 100 is written and there is no base written, you have to pretend it is 10. Just like when you write 2, there is no positive sign, you have to think there is a positive in front of it, right? Just like in the loggers also, rather writing every time base 10, 10, 10, 10, we ignore 10. So when there is nothing is there, that means base 10 is always hidden. It is not visible, but think it is there. Thank you. Hi. Now let's discuss your do this exercise right after these explanations. So let's try them. So since it is logarithms is very new, so let's try few of those things. So the very first one is 7 equal to 2 power x. So it is as simple as like, okay, so you can write it in the other way, 2 power x equal to 7. So when 2 goes on the other side, how it becomes? It becomes logger. So x equal to, when 2 goes on the other side, since it is so base to the power relationship, so when you bring this down, this goes here. When this comes here, this goes here as a base, and we write logarithms. Log 7 base 2. Is it a common logarithm? No, because the base is 2. So only when it is 10, we have to ignore it. So I mean, we don't write it. But if it is a base, any other base, we must write the base. Here it is 2. So how about this one? 10 power y equal to something 4. When we are writing, so 5 comes here, 10 goes here as a base. Y equal to log 4 base 10. We can write it as log 4. Common logarithm. No issues. This is how it works. So I'll take one other example, and rest I will leave it to you for solving it. So let's take the 100 equal to 10 power x. It is something that people say like we can write 10 square and here it is 10 to the power of x. So when bases are same, powers are also same, x equal to 2. That's a good. But here he wanted us to write a logarithm of it. So he's not asking us to derive the value. He is asking us to write the logarithm. So when you are writing logarithm, so yeah, I'm also a human being. I always get confused how to push it. So I always put LHS with 10 to the power of x and right side 100. So I always, in my mind, I think that this comes here, this goes here. Okay. Then x equal to, because x comes here, then it pushes 100 up and write log and base 10. It is nothing but log 100. So this is how we solve the things. So I would like to focus on the next set of, what is that, try this, or not try this. So this one, think and discuss. Let's discuss about this one. These are very interesting things. It will shows our understanding of the logarithms. Okay, let's go one by one. It is so interesting. Don't get confused. It is so fun. Think mathematics is little bit observing and fun with the numbers. Okay, thank you. Let's see those. Hi. Yeah, let's do the try this. So in your exercise there is a try this. So the very first one is so not try this, think and discuss. Try this you can do, think and discuss. Let's discuss. Let us think, let us discuss. So he's asking that log 0 base 2 does exist. Okay, it's a interesting question, isn't it? So he is giving the value as logarithm of 0. Okay, so all we know is like plotting graphs so far. So we didn't discuss anything else, isn't it? So let's plot the graph. Okay, what will happen? Let's see. So he is asking us to do log 0 base 2, right? So for example, for the time being, remove x and put it as like y. So and x. So log y base 2 equal to x. He is asking us what is the value of x when y equal to 0. That's what it means, right? What is the value of x when y equal to 0? When y equal to 0, it will become log 0 base 2. Okay, let's plot the graph for this one. What will happen? So we already discussed how to plot the graph for this one. This is nothing but y equal to 2 to the power of x. So quick box, x, y, when x equal to 0, y equal to 1, when x equal to 1, y equal to 2, when x equal to 2, y equal to 4, when x equal to negative 1, y equal to half, when x equal to negative 2, 1 by 4. If you don't understand this one, you can go back and refer to that graphs. I explained how to plot the graph for y equal to 2 power of x. That is an exponential graph. Okay, so here we'll write 1, 2, 3, 4. This is x. This is 1, 2, 3, 4, 5. Okay. So when x equal to 0, y equal to 1. when x equal to 1, y equal to 2, when x equal to 2, y equal to 4, when x equal to 3, y equal to 8. And here also, when x equal to -1, -2, -3, it will become half, quarter. So the graph is this one, right? We already discussed all these things in the previous class. Now plotted the graph. What is the value of x when y equal to 0? Where is our y? This is our y-axis. When y becomes 0, so y is 1, y is 0.5 here. So when y is 0, here is the y is 0 point. When y is 0, it never. So we already discussed. It will be almost touching to the y-axis, but it never touches because the value decreases. I mean, when x decreases, y also decreases by exponentially. So, but it will be like when you take x equal to -1000, it will become, y becomes 2 to the power of -1000, right? Here, when x equal to 1, it will become 1 by 2 to the power of 1000. Positive, numerator is positive, denominator is positive, so the value is positive. When the value is positive, it will be smallest amount, but it won't be touching 0. So he is asking when y equal to 0, it never becomes 0. It will be very close. X will be negatives. So when log 0.000000000 base 2, the value will be negative something. That's what it is, right? When -1000, the value will be very small, but it won't touching the 0. It never becomes 0. That's what. Y0 never happens. It will be touching, but it won't touch. That's the answer. So, yeah, interesting, right? Yeah. Let's discuss the next one. So, other things probably you can do by yourself. I'll discuss the fourth one. So, if log 16 base x equal to 2, then x square equal to 16, x equal to plus or minus 4. Is it correct or not? Okay, let's discuss that one. Hi. So, if you look at the fourth one, the question is if log 16 base x equal to 2, then x square equal to 16, x equal to root 16 and plus or minus 4. This is what our teachers taught. Like, okay, when root is there, it will be always plus or minus 4 because 4 square also 16 and minus 4 square also 16 because minus 4 into minus 4, it becomes 16. So, this is correct. When x square equal to 16, x could be anything. That's true. Whatever. It looks so confusing, right? It is looks correct because log 16 base x equal to 2 means log 16 base x equal to 2 means it will go here and it will come here. 16 equal to, it will push x up 2 square. Then because it is log, so x square equal to 16 and x equal to root 16 and plus or minus 4. Wonderful. This looks correct, right? What is tricky in this one? Okay. So let's understand the logarithms. So logarithm graph is always, we have seen like this, right? So it is y equal to 2 power x. This is the graph of this one, right? So here this is what, how to say. So here if we observe, the value is always in the positive quadrant, isn't it? So even though x takes negative value, y is always positive. Yes, we discussed y is always positive. You see that? Okay, y is in the first two quadrants only, this upper quadrant. When it is in the upper quadrant, y is always positive. These are positive numbers. So y never takes a negative value. So when y doesn't take the negative values, so y is always positive. Good. Let's write that one. How we write in the mathematically? Y always greater than 0 in the logarithms. So when y always greater than 0 in logarithms, so let's take this one. So when we say log 16 base x equal to 2, so here we are telling that negative and positive both are good. So log 16, let's take positives. So 2, 16 equal to 4 square. Good job. And let's take here log 16 base negative 4, 2, and this comes here, this will go up, 16 equal to minus 4 square. Yeah, this is good, right? So let's do a simple trick. So here we will remove this 16 and put some value like k, and assume that this x 3. Okay, we got the x equal to 4, right, in this scenario. So what is the value of k when x equal to 4 and this one? So let me erase. So this is x equal to 4 position. So we are thinking that log 16 base 4. So let's remove this 16 and put a p and think this value is some L. So so p equal to 4 to the power of L, or so take a negative value minus 3 for example. So when it is negative 3, we want to figure out negative 3, and it is 1 by 4 cube. It is 1 by 64, right? So this is p value greater than 0. That is what we thought, right? When so yeah, so here, so this is nothing but x equal to log y base 2. Y is always greater than 0. That's the equation we got. So here also, so p is always greater, p, we got the p greater than 0. Let's take in this situation. So I'll write it in the negative, red color. Let's see. This is x equal to minus 4 position. So we'll take log p base negative 4 equal to some negative 3. So for in this situation, what will happen? What is the p value? P becomes negative 4 to the power of negative 3. So 1 by negative 4 whole cube. So this is 1 by 64 negative. Look at this one, negative. So here we got p less than 0. Logarithm of something, the p should always be greater than 0. That's what we derived. The value will be always log y base 2 means y is always greater than 0. Even it doesn't touch 0 also. It is just always take any value of x, y is little bit above 0. Negative values I'm referring to. So y is always greater than 0. But in this case, if we take negative 4, so we couldn't able to plot for negative 3. The values can be negatives, x can be negatives, but p can't be negative. So we achieved a p negatives, p less than 0 we got. So that's the reason logarithms, the value and the base always be positives. So even 0 also we just discussed. So here we can't put 0 for any base. So 0, it never happens, it never touches the x-axis. So log 0 doesn't exist, and it always be positive. So if you are writing log b base a, so b is always greater than 0, and a value also, it is always greater than 0. It's a non-negative value. If we take negative values, we have seen in some cases the b also supposed to take a negative value, but b can't be negative value. So it's always be like a logarithms are for the positive values only. So we don't go with the negative values. Yeah, that's my analysis for this one. Thank you.